In this lesson, I will explain to you the difference between linear regression versus logistic regression. So I have written some information one by one we will discuss, starting by linear regression. See, the name indicates linear. Linear means in line. So the first point is that dependent variable is continuous in nature in case of linear regression. Now, what is the meaning of continuous variable or continuous in nature and dependent variable? Here I will quickly show you one example. One attribute is advertising and second attribute I am going to take sales. If I spend suppose $1 on advertising, suppose my sale is $100. If I spend $3 in advertising, suppose my sales are 400 and so on. So it means that as the advertising increases, the sales increases. So sales is the dependent variable and you can check the values are continuous in nature, right? So when we will make the graph of this advertising and sales, always keep in mind that advertising we have to take on the x-axis, not advertising means independent variable we have to take on x-axis, and dependent variable we have to take on y-axis. When we will make a graph, you can see the linear relationship between two variables. This is called the simple linear regression if we have one dependent and one independent variable. Here we have only two variables, right? Some points may lie here, some points may lie here, but some point you can see on the line. One more example, suppose the grade of the students depend on their attendance, right? As their absentees increases, here is the grade, because grade depends on the attendance, so grade decreases. So you can have the line in the inverse order or like upward order. The relation is between -1 to +1, right? +1 means positive strong relationship. If one variable increases, the other increases, right? But if all the points are online, it means we have +1 relationship. In this case, maybe we will say that we have 0.80, 0.85 and so on, but a strong relationship positive. In this case, -1 means a strong negative relationship between these two variables. If one variable increases, the other decreases, right? But some points may lie here, may lie here. The range is between -1 to +1, and the equation is y is equal to mx plus c. C is the constant, y is the dependent variable which is continuous in nature, m is the coefficient of regression, and y is the independent variable. And we had discussed so many times this equation with the help of example as well. Now take the example of our multiple variables. Suppose if we have multiple independent variables, sales is the dependent variable which is continuous in nature, then advertising, suppose we have age, sales also depends on age. Sometimes we say the experience, right? Sales depends on experience. As the experience increases, the sales increases. So if we have multiple independent variables, then it is called the multiple regression equation. Or multiple regression, we can write down m1x2 m1x1 plus m2 n2x2 so on mnxn plus c. So m1 m2 and mn, these are the coefficient of regressions. These are the independent variables and this is the constant, this is the dependent variable. Again, we had discussed very well by using Python coding as well, this linear regression. Now come to the logistic regression, which is also known as the logit regression, and we use in the machine learning. So the main difference between linear and logistic regression is that dependent variable in case of logistic regression is binary. In case of linear, it is continuous. In case of logit regression, the dependent variable is binary. Binary means it has only two outputs, that is true or false, or 0 and 1, yes and no. Whether the patient has cancer, yes or no, true and false question. If we flip a coin, maybe the head will come or the tail will come. So this is the important difference, that dependent variable is binary in nature, right? And logic regression we use in machine learning, it comes under the category of classification. And then we have to find out the best model for independent and dependent variable. Independent variables, here in this case, independent variables are continuous or binary. They may be continuous or binary, right? Binary means two outputs or categorical. And the another important difference and very, very important is probability. Logistic regression supports probability. Here we use the sigmoid function, which I will discuss in next video. Sigmoid function, quickly I can write down here for you. Y is equal to 1 divided by 1 plus e raised to power minus x. Sometimes you will see in the books they have used minus z, minus y, minus x, but all have the same meaning. E is the Euler constant, its value is 2.718. X is the independent variable. We can put the value, whatever value we will calculate from this formula, or simply you can say that sigmoid, this is the sigmoid function. Sigmoid function converts independent variable into probability range, which is 0 to 1 with respect to dependent variable. And we will discuss this in detail by using the Python programming coding in my next video. So these are the important difference, that the dependent variable in case of logic regression is binary and it supports the probability which lies between 0 and 1. So if we will make a graph in linear, I have explained very well, the graph is like this, means positive 1 or negative 1. But in the case of logistic regression, see the graph shape is like this, S shaped. Here quickly I will give you the example. See, these are the dot dot dots here, these are the dot dots. So it lies between 0 and 1, 0 and 1. Suppose these are the ages 10, 11, 12 up to 60. If the age of the person is 10 years, he is a child, whether he or she will buy the insurance. 0 means no, they will not buy the insurance. 1 means yes. 11 years no, 12 years no, and so on. As the age increases, the people usually buy the insurance, right? So when we will make this graph, you can see the S-shaped graph, which is the logistic regression graph. Here I have written types of questions binary logistic regression can answer. How does the probability of getting lung cancer? See, the answer is yes and no. Change for every additional pound a person is overweight and for every pack of cigarettes smoked per day. Do body weight, calorie intake, fat intake, and age have an influence on the probability of having a heart attack? Again, the answer is yes and no. If there is a binary output, yes and no, then we have to consider the logistic regression in machine learning. I hope the concept is clear. We will discuss in detail how we can make user program by using the Python programming coding. See you in the next lesson. Please subscribe my channel and thanks for watching.